Okay, we're going to continue in section 11.2, Introduction to Series. I want to make this statement that the main style of problem in this chapter is you'll be presented with a series and you are to answer the question, does it converge or does it diverge? It's as simple as that. It sounds easy. I shouldn't say it's as simple as that. It sounds easy, but problems can be difficult. So we're going to start out with this. Most of the series that you're going to see, they're not going to have any sort of name or any kind of label or not fit into any real specific category. However, we start off with two that do. So the first series I want to present, there we go, is the so-called Harmonic Series. And it's quite simple in structure. This will be useful in the upcoming sections. So it looks like this. We start the index at 1 and simply 1 over n. So if I were to expand this, we would see 1 plus 1/2 plus 1/3 plus 1/4, etc. Okay. Without proof, if you want to see a proof, you can go to the book. But this is a series that diverges. And I'm going to write divergent. Okay. And we just accept that as fact, and it's a useful fact that'll help us, like I said, as we move forward. I want to make an important point. Clearly what you see here is one specific series. What makes this harmonic is the n in the denominator. The n doesn't show up in the numerator. There's nothing more than just linear n. There's no squares, there's no roots, there's nothing added. N and n alone in the denominator. The point is this, is that you'll see series on occasion or use series on occasion that might look like this. What if I have 2 over n? Well, that doesn't look like that. But the 1 is immaterial. So as long as it's a constant on top, it's still considered harmonic. In fact, we can pull constants out of these because they're limits. And this could be written this way. Okay, so keep that in mind. So I guess theoretically there's infinitely many possibilities of a harmonic series, but it is harmonic because the n exists only in the denominator, and it is n to the 1, n to the first power, and that's it. Okay? Easy enough, right? Now a little more interesting and fairly common is the so-called geometric series. Okay, you work with these in chapter or in the homework problem.